Hi everybody, my name is Yasser Gayastegi and I had the wonderful opportunity to interview Nobel laureate Charles Rice with my colleague Gabriela and asked him tons of questions about his life, his career, his outlooks, his motivations, and I'm going to be sharing that with you today. So I hope you like the video and see ya.
Looking very civilized here.
We did our best,
Yeah.
with a fancy tripod and everything. The first question I have for you is, have you always wanted to become a scientist? And what was it that first made you want to become one?
Wow. Okay, this is going back a ways. It wasn't like, you want to be a fireman or something like that when you're a little boy or something like that, and that's what you end up doing. And so I actually sort of drifted around quite a bit. It wasn't like I could really, this is the major that I wanted to have. But I had a lot of really good experiences as an undergraduate, including a fantastic sort of biology teacher. I ended up sort of going from sort of the university during the summer and going to taking a course in the marine biology laboratory in Woods Hole. So that was really, it gave me a sense as to what it was like to, sort of be in an academic environment, doing research. And I really, really enjoyed that. But I still wasn't 100% sure, that I wanted to sort of do a PhD and sort of go into science. And I took a year off and I traveled in Central and South America. I was in Peru and I got I think it was a telegram from my dad. It wasn't the old cell phone in those days. And he said, you've been accepted at these places. They want to know if you're actually going to go to graduate school. And so I said, I guess I will. I went back to Woods Hole and spent the summer there before going to graduate school. And I think it was really the experience of doing a PhD, actually immersing myself in science that really committed me to, being on an academic, track. I just had so much fun doing research.
This sort of shift towards viruses? How did that happen? How did you realize?
Well, that was random chance, like many things in life.
You
Sort of chance encounters. When I went to graduate school, I was most interested in developmental biology. One of the reasons that I chose the two places that I applied to was because they had strong programs in developmental biology, in particular sea urchin development. But when I got to the place where I was going to train, Caltech, I wasn't placed in the lab studying sea urchin developmental biology. I was positioned in a virology lab. That was it. Pretty much I really sort of enjoyed, sort of virology and being able to sort of use viruses as a way of perturbing, sort of cell biology. They're relatively simple compared to the, sort of complexity of the host environment that they need to utilize. So yeah, that's how I ended up
it's
getting interested in viruses.
Random chance.
Yeah, no, I think sort of throughout my my career, it really has been random encounters.
I mean, if you were to really simple it down, sort of Atkins razor, and name the most critical steps in your career that you had to have that led your research be so influential, maybe led you to getting the Nobel Prize, what would you say they were?
I think just sort of curiosity about how, viruses as these relatively simple entities, relative to us in terms of the genetic information that they have to deal with, sort of how sophisticated they are. One of the viruses that we were working on is a virus called yellow fever virus. I guess what sort of got me on the path for sort of this recognition, and I say this recognition with the Nobel doesn't, a person or persons are singled out for this, but I mean, we're really talking about something that involved thousands of people working very hard to make sort of important discoveries and breakthroughs. The agent that was responsible for this mysterious form of liver disease after transfusion, non-A/non-B hepatitis, was then, found to be so-called hepatitis C virus, and it was very similar in many respects to yellow fever. So some of the studies that we've been doing on this sort of model virus that we already had a vaccine for actually put us in a strong position to begin working on the hepatitis C virus.
And in this whole process, was there a moment where you realized your research would be groundbreaking?
I don't think so. I mean, I sort of view, if you discover something or if you produce something that was, sort of difficult to do that's important, kind of that's what we do, sort of as scientists. Now, hepatitis C virus turned out to be a lot more challenging than these other viruses that we were used to working on because the virus didn't grow. Yeah, that turned out to be a multi-year endeavor, which sort of eventually there were some breakthroughs made by us and others that sort of gave rise to a useful system for drug development. And I think sometimes when you really want to do something and it's somewhere between hard and impossible, but you just say, we got to do this, come hell or high water, it doesn't matter. Then, even if it doesn't work tomorrow, you sort of come back the next day and you go, well, I'm going to try this and see if that works. That was maybe kind of a pig-headed, sort of mentality of just being stubborn that, sort of you're not going to be defeated by this, this pathogen.
I mean, and then one day you got a call from Sweden.
Yeah, that was pretty bizarre. I mean, I was not expecting that at all. Well, for me, it was bizarre because this was in October of 2020, and I was in the laboratory in New York City, sort of by myself. The phone rings, at, I don't know, 4:30 in the morning or something like that. Who's calling at this time of the morning? And so I sort of went out. It was still dark. I didn't want to start turning on lights because I was hoping to go back to bed for a couple of hours. Eventually it stops ringing. So I go back towards the bedroom and it starts ringing again. And this time I'm actually getting kind of mad because I figure, it's some sort of persistent wrong number, or maybe it's somebody in the lab trying to, sort of play a joke on me or whatever. And I guess I pushed the talk button as opposed to the cancel the call button. I guess the other thing that was funny about that was there would be somebody from public relations giving me a call because they like to interview the laureates soon after they, sort of hear about this. The phone rings, about 30 minutes later, and he says, well, we like to have the laureates, have their picture taken as soon as possible after there was nobody there to take my picture. And he said, well, why don't you take a selfie? And I'd never taken a selfie before. And so there I was sort of trying to figure out, sort of how to do this sort of on my cell phone. I think eventually I succeeded. But after, taking pictures of random stuff on the walls, that was a very different and very memorable morning.
On the second part, we would like to switch to more global scene and
Okay.
ask your opinions about a couple of things.
All right.
So to start off, what do you think is the most important problem standing in front of biomedical research today?
Oh, boy. I don't know where to start,
Oh.
in terms of the most. I think one of the problems is really just sort of getting sustained, funding. You have to remember that a lot of the real breakthroughs that have come are from really more sort of fundamental curiosity-driven research. Sometimes people would question, well, why are you, say for instance, studying these little RNAs in a worm?
Yeah.
What good is that? The sort of discovery of microRNAs actually turned out to have a convergence with sort of work on hepatitis C, because that virus, rather than being inhibited by these small microRNAs, actually requires them in order for replication, one that's highly expressed in the liver. CRISPR is another example where you're going to study this thing that you found in sort of microorganisms that are growing in yogurt, and that's going to give rise to a transformative technology for research and therapy. No way.
Yeah.
So, I think we really need a balance of things that are really sort of just fundamental curiosity-driven science, and then also keeping your eyes open for things that, will have a translational, value for improving human health.
Yeah.
Things in sort of human behavior and everything in life seems to be cyclic. Yeah. And that's also true with research funding. And so when research funding goes down, people get discouraged, and then they switch to doing other things. And so it doesn't take sort of very long, sort of on the downside, in order to discourage many people in an entire generation of scientists from going on that path. And then I guess the other thing too is sort of just the anti-science, vaccine hesitancy, and so on that we're facing now, which doesn't seem to be an issue in Sweden, because in Sweden I think the population appreciates the sort of benefits of science. But if you look in the United States now, from the time when I was sort of growing up in, let's say sort of the 60s and early 70s, I think people appreciated the benefits of science. You get somebody walking on the moon. That seems to have decayed away. And so that's a little bit discouraging, and it's a challenge that I think we have to confront. So it's always a matter of sort of prioritizing things. Obviously, as scientists, we're not necessarily the ones that sort of make those decisions.
What would you say is the biggest advantage of being in academia and with the science?
Well, I think again.
What do you like?
I mean, it's not like in academia you can do everything, right?
Yeah.
That you want to, sort of without limit. So I think that one of the things that I've enjoyed about it is that the level of freedom it gives you to pursue something that you're curious about or that you have a passion for doing. And actually having some ability to be self-determining and not necessarily, being told by somebody else, do this.
Yeah.
And that's very much the way I, sort of my lab operates, in the sense that I don't tell people what to do. I tell them, well, maybe this would be a good idea, but it's really up to them how they're going to sort of spend their time. So I think that's the advantage of it. But we do have to pay the price. I mean, we have to figure out how to pay for this.
Okay, just to wrap it up, last short question. If you were to give an advice to young students who are just starting their scientific career and want to maybe follow in your steps, what would it be?
I don't know. I think you just have to have a sort of a real passion for what you're doing. Sometimes you have to try a lot of things in order to sort of find a path forward. And I think if you're really excited about sort of what you're doing, that kind of something doesn't quite work out, or you sort of make a mistake, so the experiment isn't working and you have to repeat it. I mean, you have to be I guess double down and say, okay, well, I'm going to make it work.
Yeah.
And because I really want to know the answer. And so I think that's probably the most important criterion to have. And I would say it's not just science. It's like anything in life. You don't want to sort of be getting up in the morning and dreading what you have to do that day. I mean, that's going to be what you spend most of your life doing.
Yeah.
And so ideally you would like to have that be something that you would be pursuing as a hobby.
Yeah.
So I think that's what I would say.
That's good. Yeah.
And sometimes it takes some trial and error, to find the right fit.
Would you say that you've worked doing your hobby?
Oh yeah, no, I think, well, I mean, science is my sort of hobby. I mean, that's sort of but I do have a few other hobbies. Most of them sort of oriented around the dogs.
Oh, that's so nice.
Sort of like playing frisbee with sort of the dogs. I sort of like to cook and food. And,
that's lovely.
And again, some of my undergraduate courses at UC Davis in California got me interested in wine and winemaking. So I kind of like that aspect, I guess, of food and wine and so on. But no, I think with the laboratory, and I guess what you find is when you get this kind of recognition, it's almost like having another full-time job. In terms of the interactions that it catalyzes with people, and not all of which you want to say no to. And, it's kind of hard to balance all this stuff.
The request for interviews from uni students.
Yeah.
No, actually, I mean, one of the things that I really enjoy doing is, I'm sort of given a choice of, going to some big, technology conference and wherever you get, asked to do this a couple times a day or whatever. It's when I get invited to sort of interact with students, and because I mean, you guys are the future.
Great to hear that.
No pressure, but
Okay.
we got a lot of challenges here, so it's going to sort of fall on sort of the next generations to figure out how to move things forward in a positive way.
We'll try our best. I think it's safe to say we'll try our best. Now, sadly, we have to finish. But it was lovely talking with you. We're so grateful for this opportunity.
Oh, sure. Absolutely.
And you're welcome back at KI anytime.
Yes.
Okay, all right. Well, it's a wonderful institution. And you guys should be happy to be studying there.
It was really sweet.
It was a pleasure, really.
It was.
You got it?
Yeah, I did. Thank you so much.
Yeah.
It was a pleasure to have you.